This is Algebra 2. I'm asked to find all the roots, x equals whatever, of this polynomial. And I can see I don't have the same ratio. This is 12 to 20, which is 6/10 or 3/5, and this is not 3 to 5. If these were in the same ratio, then I could factor by grouping. Can't factor by grouping, can't divide anything out, so I'm just going to have to use the rational roots theorem, find our potential roots, test them with synthetic division, and then once I find a root, then hopefully I can handle whatever the reduced polynomial is. So the rational roots theorem, take whatever the constant is, 5, and it's plus or minus all the factors of 5, so just 5 and 1, divided by all the factors of the leading coefficient, the one on the whatever x is with the highest power. Sometimes they'll jumble these and they'll put x with the highest power, not in the beginning, just to throw you off. So it's going to be 12, 1, 6, 2, 3, 4. So that's 1, 2, 3, 4, 5, 6, 12 different roots I have to check. Well, I'll check the easiest ones first, 1 over 1, and plus or minus 1 over 1. So I'll try plus 1. I'm going to use synthetic division, 12, 20, minus 23, 5. I've got every power of x, 3, 2, 1, and then just the constant. And I'm going to try 1 first, 1 over 1. I'm trying the simple ones first. So I bring down the 12. 1 times 12 is 12. 12 plus 20 is 32. 1 times 32 is 32. That's plus 9. 1 times 9 is 9. And that's 14. So the last number isn't 0. That's not a root. 1 is not a root. So now I will try negative 1. Let's try this one. There's the 12. That's negative 12. 8. Negative 8. Negative 31. 31. Not 0. So negative 1 didn't work. All right. I'll try 5 over 1. I'm going to, until I find one, I have to keep trying. So 12, I'm just trying the integers first. 5 times 12 is 60. This isn't going to work. 80, 400, 3 something, bloop, bloop, 1500 something. Not going to work. Not equal to 0 at the end. So 5 isn't good. I don't think mine is 5, but I'll try it. There's 12 minus 60, negative 40, negative 200, negative 223, positive 1,000 something. Nope, that doesn't work. All right, the next one I'll try is 1 over 2. 1 over 2, plus 1 over 2. And then I'll try negative 1/2 if that's okay, or if that one doesn't work. 12. 1/2 times 12 is 6. That's 26. 1/2 times 26 is 13. Negative 23 plus 13 is 10. 1/2, negative 10. 1/2 times negative 10 is negative 5. 5 plus negative 5 is 0. All right. X equals 1/2 is one of the roots. Found it. And now I will 1 degree smaller than the original, so this is 12x squared plus 26x minus 10. And then I will divide everything by 2. The 2 will just drop out because 0 divided by 2 is 0. So 6x squared. You'll get the answer if you don't divide, but the numbers will be bigger and maybe harder to figure out. And now I do 6 times 5. Negative 5 is negative 30. I'll put an x with a 6 here and an x with that original 6 under. Factors of negative 30 that equal positive 13. 2 and 15. 15 times negative 2. 15 times negative 2 is negative 30. 15 minus 2 is 13. So plus 15 and then minus 2. Now I'm going to simplify these. X plus 5 goes into 3 goes into 15 5 times. 3 goes into 6 twice. And then 2 goes into 2 once, and 2 goes into 6 3 times. And now if I wanted the factors, since these aren't integers, I just put the factors would be 2x plus 5, and the other factor would be 3x minus 1. Whatever's left in the denominator that I can't simplify more, I just put it with the x. But I don't want the factors. I want the 0, so I'm just going to set each one equal to 0. So x is going to be x plus 5 halves, subtract 5 halves from both sides, negative 5 halves. X minus 1/3, add 1/3 to both sides, 1/3. So x equals 5 halves, 1/3, and 1/2. And if I graph this, there's the function. I get negative 5 halves, which is negative 2.5, 1/3, 0.333, and 1/2. So I'm doing homework, so I'm going to check it. Again, on test day, this, I believe, is a no calculator, so you can't use your calculator. If you could, graph it first, see if you can find a 0, and then use synthetic division or polynomial log division to simplify that. And then get your reduced, and then figure out what the roots of that are. But anyway, this one, I use the rational roots theorem, the constant, all the factors of the constant divided by all the factors of the leading coefficient, the one on the variable with the highest degree, and plus or minus, and every one of those combinations is a possible factor. I just have to check each one, in this case with synthetic division, and I found 1/2, negative 5 halves, 1/3.